Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 12, sound. So in the first part, I gave you the introduction to the lesson where we discussed on like what is the exact requirement for the production of the sound, how exactly the sound propagates, right? And there were many different points that we discussed on like what is wavelength, what is time period, what is frequency, and so many more terms, right? So we have discussed them all in part 1, and part 1 was like just doing an introduction for you to the lesson sound, right? And then in part 2 we started with the exact lesson where we have studied the characteristics of the sound, the propagation of the sound, the medium through which it travels, right? What are sound waves? Then we discussed on two different types of sound waves, that is transverse wave and longitudinal wave. So we have studied many things in part 2, right? So till now you have acquired so much information on this lesson that if I tell you to write a short note on sound, you will be able to at least write half or one of the page, right? Like for 4 to 6 marks you'll be able to write it if we accumulate all the information that we have gathered in part 1 and part 2. Now as we are on to part 3, in this part I'll be like starting with the other part for the lesson. So everyone make sure that before we proceed on to the next part, you all are clear with the previous part of the lesson, because like if you are skipping the previous part moving on to the next, then it's like some or the other how you are lacking in some like you're lacking with some or the other information with you, right? So make sure like you are clear with each and every term, each and every concept that we have studied till like part 2. Okay, so before I proceed with this part 3, I want each one of you to please revise each and everything that you have like taken in your book. Whatever notes you have made in part 1 as well as in part 2, please write that in your, not write that, you have already written it. Please revise it once. I hope every one of you have started revising everything from part 1 and you should be clear with each and every term. Okay? Now I want each one of you to go through the slides that have been shown over here. You have to go through each and every activity, come up with the observation conclusion for it. You have to revise it all as such. Okay? I hope you all are going through this slide, propagation of sound, how exactly the sound has been produced, and the activity as well for that. After studying about production of sound and this activity, we discussed on propagation of sound, like how exactly the sound propagates. And we studied that like a medium is very important for a sound to propagate, right? And the medium can be solid, liquid, or gas. It can be any medium, right? So here we have more information on the mechanical wave and how exactly the sound reaches our ears and we are like able to listen to the sound, right? So there is some displacement in the particles because of which the sound becomes audible to us. So I want you all to please go through the slide as well quickly. Then after propagation of sound, we discussed on how exactly the sound propagates through air, and over here we have discussed on like what is compression and what is rarefaction, right? So compression is when a vibrating object moves forward, it pushes and compresses the air in front of it, because of which a high pressure has been formed, and we know that high pressure, that region of high pressure, as compression, right? And then what is rarefaction? When the vibrating object moves backward. Okay, so when it's moving backward, it's going to form a region of low pressure, and we call that region of low pressure as rarefaction. I hope you all are going through this slide. After discussing on propagation of sound through air, we discussed on like how exactly a vibrating object or a vibrating object produces a series of compression and rarefaction, right? So I want you all to please go through this, because you need to know how compression looks like and how exactly rarefaction looks like. After this, we discussed on that sound needs a medium to travel, right? So we all know. So over here we have discussed on about the mechanical wave, right? So sound is a mechanical wave and it needs a medium to propagate. We all know this, right? So I want you all to even go through the exercise, that is the activity that has been given. I hope you all are going through it. After this, we discussed on that sound waves are longitudinal waves, right? So over here we have discussed on longitudinal wave as well as transverse wave, right? So I want you all to please go through it and even go through the activity with respect to slinky. Okay? I hope every one of you are going through it. I hope you all are going through it. Then the last part that we discussed in the last class was the characteristics of the sound wave, where we saw the unit to represent the sound wave, the wavelength. We discussed on what exactly wavelength is, right? Everything in detail over here on this slide. Okay, so please go through it, everyone. After discussing about the characteristics of sound wave, like now the next thing that we will be discussing on is the frequency. But before that, you should be knowing the definition of wavelength, about the crest, about the trough, and everything, right? So please go through it, everyone. I hope every one of you are going through it because this is one of the like important slide for us. Okay, so make sure you know about this. Now the next thing that we need to discuss after this characteristics of a sound wave is about the frequency. But before that, if you have like when I scrolled, if you might have had a look on that, we have a diagram to discuss, right? So we can see that it has been labeled as speaker, which is the source of sound. So whenever we are playing the speaker in that case also, you will find out that there will be continuous compression, rarefaction, which is going to happen, right? And you can see the pressure variation and density variations that have been given. So we'll be like this is how compression and rarefactions are like always going to be there when it comes to like sound. Okay, so on the basis of that, we on the basis of this compression and rarefaction, we make this density or pressure like how exactly the crest or the trough looks like. Okay. After this, like now we have the frequency of sound wave to discuss what exactly it is. See, now you know how exactly the sound propagation is happening, right? So when sound is propagated through a medium, the density of the medium oscillates between a maximum value and a minimum value. Where will the density of the medium oscillate? It is going to oscillate between, there will be a maximum value for that and a minimum value for that. Okay, so whenever these values are changing, the density of the medium from maximum value to the minimum value is going to change, and it's again like first it will move on from maximum value to minimum value, and after that it again goes back to the maximum value and is on like oscillation. So that is going to be a continuous part for that. Okay, what will happen, it will move from maximum value to minimum value, and this is how it works. And after that, the number of oscillations per unit is called the frequency of the sound wave. What exactly it is called? It's called as frequency of the sound wave. Whatever number of oscillations have been produced in unit time is called the frequency of the sound wave, and we represent that by the symbol lambda, or like no, wavelength is represented by lambda. This we represent by nu. It's like a v, like you write it like a v, and we know that as nu. And the SI unit for frequency is hertz, and we write that as hertz, that is capital H and small z. Okay, so see, we have the diagram as well. If the wavelengths are short, short wavelengths means lots of waves, high frequency and high sound. Okay, what does it mean? Short wavelength means lots of waves and there will be high frequency and high sound. And long wavelength means fewer waves, low frequency and low sound. Okay. Hmm. I hope you all are writing about and you have understood about this frequency of the sound wave, and you all are even writing about it. I hope everyone is writing about the frequency part. Now we have time period, amplitude, pitch and loudness, speed to discuss. Okay, so we'll discuss them all. but please be clear with this concept first. I hope you all are writing this in your book. After this frequency of the sound wave, the next thing that we have is time period of sound wave. Okay, so the time taken for the change in the density of the medium from a maximum value to a minimum value. Okay, what's happening? Whenever the density of the medium is changing from a maximum value to minimum value, and whatever time is taken for that, okay, that time period, that is known as the time period of the sound wave. Okay, so I'll read the definition again. See, we know that the density of the medium is going to change from maximum value, it will come to minimum, then again maximum, then again minimum, right? So this, whenever like this density of the medium is changing from maximum to minimum value, and whatever time is needed for this change, for the change in the density, we know that as time period of the sound wave. Okay, so the time taken for one complete oscillation in the density of the medium is called the time period of the sound wave. What is time period? Time taken for one complete oscillation, one complete, for completing the one complete oscillation is going to a maximum value, coming to a minimum value, and then again going to a maximum value. That is one complete oscillation. So the time taken for one complete oscillation in the density of the medium is called the time period of the sound wave, and we represent that time period as capital T. Okay, now because it's with respect to time, so the SI unit of time is second, and we represent that as small s. How do we represent that as small s? Okay. Then the frequency and time, they have been represented as follows. So T is equal to 1 upon nu, or nu is equal to 1 upon T. So there's a relation that exists between both, right? So I want you all to please write all the important points from here. that is from time period of the sound wave, and you can see the frequency waves which have been shown, where we have the high frequency wave and the low frequency wave that has been shown, how exactly it's going to be, how the wavelength will be, right? So please go through this, write all the points from this slide, everyone. I hope every one of you are writing all the important points. I hope you all are writing about the time period of sound wave. Now after this time period, the next thing that we have is the amplitude of the sound wave. So how can you define amplitude? Amplitude of the sound wave is the height of the crest or the trough. What it is? It is the height of the crest or the trough, and we represent that by capital A. Now why I gave you why I told you that second definition, not the one, because for understanding it, the second definition is the easiest one, right? But one like if you have to write it, you can write any of the two, and you can even define amplitude as the magnitude of the maximum disturbance in the medium on the either side of the mean value is the amplitude of the sound wave. What it is? Magnitude of the maximum disturbance in the medium on either side of the mean value. So according to me, every one of you should go with the second definition that has been given, because it's the easiest as well, right? So SI unit of this amplitude is the same as that of density or pressure. Okay. I hope you all are writing on this. Okay, after amplitude, like here we have the wavelength and amplitude, which has been explained. Okay, wavelength is the distance between the crest of two waves that are next to each other, and amplitude is how high the crests are. So amplitude is the height and wavelength is the distance between the two crests. Okay, so you should be knowing the difference between the wavelength and the amplitude both. Okay, so amplitude is the height, or like how high the crest is, and wavelength is the distance. Okay, I hope you all are drawing and writing this part in your book. after this, like, last topic that we will be discussing today is about the pitch and the loudness of the sound. Okay, so what is pitch? The shrillness or the flatness, the way that we speak, that is our pitch. Okay, so pitch of sound, it depends upon the frequency of vibration. So frequency plays a very important role when it comes to discussing about pitch. Okay, so if the frequency is going to be high, the sound will have high pitch, and if the frequency is low, sound will have low pitch. Okay, so this is how high and low pitch, like, is very much important, and it depends upon the frequency. Pitch always depends upon the frequency of the wave. Okay, then after that we have this structure which has been given. See, short wavelength means lots of wave, high frequency and high sound. Long wavelength means fewer waves, and low frequency, low sound. Okay, so if you can see, the waves are all traveling at about the same speed. So this is the number of each wave that will reach the ear in a hundredth of second. In how many second? Hundredths of second. Okay, so I want you all to write this in your book and keep. I hope you all are done writing about this pitch and loudness of the sound. So always remember that the loudness of the sound depends upon the amplitude of the frequency. If I'm speaking, like, if the sound is low, the loudness of the sound always depends upon the amplitude of the vibration. And if the amplitude is bigger, the sound will be loud, and if the amplitude is smaller, the sound will be soft. Okay, so you need to know, if amplitude is bigger, sound is loud, and if amplitude is smaller, the sound is soft. Okay, I hope you all are writing this in your book, everyone. After this, in the next class, next part, I'm going to start with the speed of sound, where we will be discussing on the speed of sound in different media at 25 degrees Celsius. Then after speed, we will be discussing on reflection of sound through an activity. Okay. Then after this reflection of sound, we'll be discussing on echo and reverberation. Now, echo and reverberation are like some. Echo is a normal term that we even use in our daily life, right? But reverberation might be new to you all, so we'll be discussing on that as well. Then after that, we will be discussing on the uses of multiple reflection of sound, range of hearing, then uses of ultrasonic sound, sonar, structure of the human ear, and then we will have the summary discussion for the whole lesson, sound. Okay, so before I stop with this part, I want you all to tell, like, I want each one of you to know the concept, to know whatever we have studied so far, okay? So that you can explain it in your own words as well, which is very important, okay? Now, after discussing the summary, we have a few exercise questions, like there are 20 to 22 exercise questions which we have, which we will be discussing at the end of the lesson. So before we proceed with that, I want each one of you to please go through this exercise questions that I'm going to show you on that are visible on the slide. Please go through them, everyone. I hope you all are going through the slides. So this is the last question that we will be discussing at the end of the lesson. Okay, sound. And I hope every one of you are clear with whatever we discussed in this part for the lesson sound, right? So whatever part has been left, I'm going to continue with that in the next part. Thank you everyone.